Hello everybody. I thought it's time for a new video. Full lockdown here in Belgium, or more or less a full lockdown in Belgium due to COVID-19. So time for a let's say a quick video about a couple of interesting tools you can use on your local machine to do Kubernetes development. What we'll do in this video is look at a couple of things. First of all, we'll look at how easy it is to spin up a Kubernetes cluster locally on your machine using tools such as k3d and k3s. And secondly, also look at how easy it is to provide a public IP for locally running services. So what we'll do is something which is similar to what you see here on the diagram. So I have a tool installed called k3d. That tool, I can use that to quickly spin up a cluster. But in the background, that uses a Docker image that runs k3s. So basically, k3s is a cut down version of Kubernetes that can run in a Docker container by itself. And then by that kind of magic, I have Kubernetes running on my local system, but it's k3s. It's not a full Kubernetes, but very, very similar. Then we can use that Kubernetes software to run our own applications. I have developed quite a while ago an application called Nasnet Go. It's a Go application using TensorFlow libraries and so on to use the Nasnet deep neural network to recognize about 1,000 different types of objects, and we'll use that as an example of an application we run locally on the machine. But I also want to expose that application that runs locally on my machine with an IP that's on the internet, so everybody can actually connect to it, and I can do other kinds of testing with that. Now, that's not that simple. There are several tools on the market for that. One of these tools, actually a great tool, is the inlets tool, and another tool called inlets operator configures inlets simply on your Kubernetes cluster, as you'll see in a moment. Now, of course, if we want a real external IP to connect to, we'll have to provision that in some way on the internet. The inlets tooling, or inlets operator, the inlets tooling itself supports several kinds of cloud providers that actually can run a small VM that contains the inlets server components, and that VM will actually be used to accept connections, tunnel them to our internal network. So what you see is, in the end, when everything works in the demo, and hopefully it works, when everything works, we can actually from the internet connect to this inlets droplet on a certain port, and then through a tunnel that's established, a tunnel going from my laptop to this server component here, over that existing tunnel, I can actually connect to my Nasnet application. Or that's, of course, the whole idea about it, and let's see if we can make this happen fairly quickly. Now, the first thing we'll have to do is, of course, we'll have to install or get that Kubernetes, that k3s running, and we use a tool called k3d for that. So k3d has one of the commands is the create command. So we use k3d. I'll just clear the screen, it's a bit easier for you to follow. So k3d create, but we'll give it a couple of parameters, or one parameter actually. We want to give it an argument where we state that we do not want to deploy Traefik, because k3s is coming with all kinds of add-on tools. We don't need Traefik in this case. Traefik is an ingress controller. We're going to use a service of type load balancer and expose that on the internet, so we don't need Traefik in this case. So k3d create, and that's it. That has happened now. It's already done. It's creating it, of course, in the background. And just like with any other Kubernetes server or cluster, I of course need a kubeconfig. The k3d tooling has a command to actually get the kubeconfig using k3d, and of course we use that here to get the let's say fill the kubeconfig variable. If we echo kubeconfig, we'll see that this is the actual path to the kubeconfig file that we need here in this case. So now I can do k get node. Yes, I aliased the kubectl or whatever you call it, the kube control tool to k. So k get node gives me indeed, okay, I have Kubernetes running. I have only one node here, right? That's great. I think that makes it that makes the k3s cluster ready. Now let's look a little bit at what is behind the scenes here. So I'm starting up code here. Why code? Because yeah, code has an easy way of actually connecting to my Kubernetes cluster. Let me enlarge this a little bit here. Yeah, that's it. I'll just leave it like this. I think it's clear enough. And here you can see the k3s default. Of course, it's a new cluster, so the normal namespace you can expect. I have my node here, and of course there are no workloads running yet, no deployments, no pods are running. That's just how it is. So my Kubernetes cluster is running. I have access to it using the kubectl tooling or kube control tooling. Now we want to actually make sure that we have the software running that creates this, let's say, external IP and external VM for us automatically, and creates this inlets tunnel. And that software we'll use is inlets operator. Now, if you look at inlets operator on GitHub, you'll find it there. By the way, this tool is created by Alex Ellis, who has created many other great tools and applications, especially also OpenFast, for instance. So if you want to have more information about how does inlets work and what does inlets operator do, be sure to check out GitHub here. So we'll install that tool, but we'll install that tool using another tool created by Alex Ellis, which is Arkade. And Arkade makes it also easier to install all kinds of applications on a Kubernetes cluster, which includes a k3s cluster. And we'll use Arkade to install inlets operator on the cluster. That's the easiest way of doing it. Now, because I am going to use DigitalOcean, and yeah, the inlet operator will need access rights to do something in DigitalOcean, you'll see that in my home folder, I have a file which is called DO access token, and that's an access token for DigitalOcean. That if you have access to it, you can actually through the API here create such an access token that has the necessary rights to do what you need to do within DigitalOcean. But that's something that you'll need. By the way, other providers are supported. I'm just using DigitalOcean here because I have an account for that properly set up with my company credit card and so forth. You can see my usage here. This month it has been incredibly high, as you can see. Now let's do the actual inlets operator installation. So I'm going to use Arkade. Arkade, I installed it already on my Mac. You'll find how to install Arkade on GitHub. So I'm going to do ark install, and inlets operator is of course one of the supported softwares to install using Arkade. I'm going to use the provider in this case as an example, DigitalOcean. Other ones, as I said, are supported as well. Yeah, I need to specify in which DigitalOcean region I want to deploy it. I'm going to use AMS3 because AMS2 was a bit full last time I checked, so we'll just use AMS3 for now. And then the token file is of course in home/do, and we can actually give it like this. That's of course important because otherwise we don't have access rights to DigitalOcean to deploy our exit node VM. So we install it. Now you'll see if you look closely that is using Helm 3 in the background. That actually was installed by Arkade as well. So these things you don't really have to worry about. That's done for you automatically. Yeah. And now we have inlets operator installed, and we can actually check that using our Visual Studio Code tooling. So if you go back to VS Code, you look at the deployment, there you have the inlets operator, and I can actually look at the logs to see what it's doing. And it's kind of quietly sitting there waiting for us to deploy an application. that it needs to do some work for. So if we deploy an application that is wanting to expose your application using a service of type load balancer, for instance, this tool will start and will actually then provide the necessary tunneling components for us to reach all of that. Now, to actually make that work, we are going to install the NASnet Go tooling, and that's the application that I've created myself quite a while ago. You can find it also on GitHub. So if you go to github.com/gbake/nasnet nasnet-go, you'll find the source code of the application. So it was written in Go, it's using TensorFlow, and so on and so on. And of course, on Docker Hub, you'll find an image which is completely, everything compiled properly and working properly. So Gbake and NASnet is the image. If you check the image on Docker Hub, you'll see it's quite a hefty image. So if I click on that and I'm going to the tags, you'll see there's just the latest tag there, and it's 1.19 gigabytes. So it will take some time to pull down. So let's already install this, and before we continue with other things. So let's clear the screen. I think it's in the, yeah, I already cloned it here with Git. So a Git clone of this is in this folder. There's a YAML folder in there. The YAML folder contains the NASnet YAML file, right? So if we actually open that with code, the NASnet YAML file, what you'll actually see, it is very simple. It's a deployment. The deployment deploys the NASnet container, just one replica. That's basically it. And then it also has a service of type load balancer that exposes the application on port 80. It uses port 9090 to actually connect to the container in the background. And you can forget about these annotations here. They have nothing to do with the demo we're doing right now. So that's nothing special. It's a simple application, a deployment, and a service of type load balancer. But let's actually deploy that, right? So let's do k apply -f NASnet YAML. The deployment starts, and then, and that you will see here, this this NASnet application. So that's the second one you see here in the line, NASnet app. This container creating will take quite a while. I'm on Wi-Fi here. It has to, because I actually started a new cluster, a new k3s cluster. It didn't actually pull down the image yet, so it has to pull down 1.19 gigs from Docker Hub and then start the image. What you'll also see now is that something else is happening as well. You see a svclb NASnet. You see there. You see a NASnet tunnel client as well. These are actually things which are done by the inlets operator. Yeah, these things happen automatically. And if we actually go to our services, so k-get svc, you will actually see that there is now a service, NASnet, the one I showed you earlier, the NASnet service of type load balancer. It uses an IP locally here as well, but because now the inlets operator is doing its work and apparently already provisioned a droplet on DigitalOcean got an external IP, it also adds that here actually. So I can see the external IP of my droplet here already. But of course nothing will work yet, because if I'm going to my pods, you see container creating for the NASnet container is still busy because it's such a big image. So we'll wait a moment and see what happens there. Now in the meantime, we can actually go to our inlets operator and look at the logs again. Actually it's here, it's open. And you'll notice that while it was sitting there and doing some syncing happily in the background, from the moment that the service appeared of type load balancer, the inlets operator it's just watching for that, right? So it sees that it's being done. It then says, okay, I need to create a tunnel, but to of course create a tunnel, I will have to provision a host if it doesn't exist yet with DigitalOcean. And hopefully that worked correctly. Now I see there are no errors there. So if you don't see your host being provisioned, make sure you check the logs here, and indeed then there you'll see that host provisioning failed for some reason, right? I had a very silly thing while I was working with this tool in the beginning, that when I was deploying the tool with Arkade, I actually did something like instead of dash dash region, I did dash region, and tool will happily install. It will happily install inlets operator, but of course it will fail because it doesn't know where to actually deploy everything. So make sure you type everything correctly and don't make silly mistakes like I made it. Now let's check out DigitalOcean and see if there is a droplet for us configured. So I refresh this, and there's indeed a droplet there. It's a simple Ubuntu image, 512 megs of RAM, 20 gigabyte disk, and it's deployed, as I said, during the Arkade provisioning or provisioning with Arkade. I use the AMS3 region, and here you see the address, 178 and so on, 218 in the end. And indeed, when we are, I'll just Control-C this, clear. When we get our services, you see that same IP appearing here as well, right? It's the same IP here. So that IP I can actually use to go to my application. But of course, if the application, in my case, a big container, right? You know that it didn't spin up correctly. Yeah, then in that case, I should of course make sure I I paste the address correctly. Of course, nothing is happening here. So it says, yeah, I'm trying to reach this, but there's nothing listening at the back end there. So I'm sorry, I can't actually find anything. Now you can see it here, dial TCP. It says 1043.246. What is this? Where is this actually coming from? Of course, we have more. It's an internal address there. So if we refresh this, and we look at our deployments, and we look at the NASnet app, for instance, and we look at this one here, yeah, it says pending. It's still not there yet because he's still pulling down the image and deploying that for us. And when this, of course, is ready, when this turns green, well, then eventually I will be able to reach it here. So again, if I go back to the drawing here. Basically, everything is now complete. So you saw it's very simple to create a cluster, a k3s cluster on your local laptop with a tool called k3d. Very simple to do. From the moment that you have run that tooling with create, you get your own k3s Kubernetes cluster running on your Mac in a Docker container, right? And by the way, I didn't show you that, but if you look at Docker now, you'll see that it's running here for 30 minutes. The k3d tool actually spun up a container, and that container is running k3s, and that provides you with Kubernetes on your machine. So this was done. We installed the inlets operator with Arkade. We made sure the inlets operator could provision a droplet on DigitalOcean, and everything is actually ready. So we can do, as you have seen here, we can connect to that. It tries to actually tunnel the traffic, but there's nothing listening there, so we of course get an error. So this works. The tunnel is actually working and up, but we're just waiting for the NASnet container to spin up and respond to our question. So we have to be a little bit patient. Yeah, I could fast forward this, but I don't think it will take that long anymore. So just let's check this here. Well, not yet. We'll watch it and see what happens. It shouldn't take that long anymore. Yeah, maybe an important thing for you to know is that I'm using let's say the open source version of inlets, right? So if you go on GitHub and you go to inlets, you will also see that there is an Inlets Pro version as well. And Inlets Pro lets you do a couple more things here. Yeah, for example, it supports automatic TLS encryption using Let's Encrypt and other kinds of enhancements. And then of course this requires a paying license. But if you just need simple connectivity using HTTP for testing and so on, Inlets, the open source version, is of course enough. But do be aware that if you need a bit more, and you want to be using these things also professionally, because there can also be professional need to actually run this kind of tooling, that there's a pro version available as well, which I really recommend because it's great, great software. So let's check again. Yeah, there it is. It's running. So the NASNet container is running now. I'll just show it to you again. There you have the NASNet container running, which means that the tunnel now should not give me an error. It should normally route the traffic to the NASNet container running on my Mac. So public IP from anywhere in the world, I can connect to this IP. I will end up on my MacBook on an application running in a container, which is actually a Kubernetes cluster. So it's a little bit weird, but it all works pretty nicely. Yeah, just let's try the application. It's very simple. It just needs an image. I take a wolf spider. I think it's really a wolf spider. Let's see if you can, if that deep neural net can see that it's correct. And indeed, it sees it's a wolf spider. It's not too sure though, 0.62, so 60% sure. But the application is running and working locally on my machine. So great. This was actually what I wanted to show you. Really recommend these tools for local work on your system. Remember, k3d, k3s, a tool like arkade to easily install software on your local cluster, a tool like inlets operator and inlets to get a public IP for your local containers. Really great tools, easy to use, and so recommended for your use when you're doing your daily development or infrastructure work. That's it for now. See you again some other time. Bye bye.